Hey folks, welcome to More Than a Refresh, the T3D sessions. This is a Postgres Pet Peeves with Yurii, who's omnigress but not omnigress anymore. Yurii, explain that a little bit and then go into your pet peeve.
Absolutely. So I started a company called Omnigress about maybe 2.5 years ago. And we basically are trying to solve big pet peeve of my own. And that is building complicated systems that interact with data is still extremely complicated. And so Omnigress started on that by collapsing the entire backend stack into Postgres. So we had initial success with that, but we couldn't quite scale the sales given everything that has happened in the tech world. So
Mhm.
we basically stepped back and actually created a different shape of a product that is not Postgres specific, although very Postgres friendly, that basically allows people to build data native operating system for agents and everything adjacent to that. So, and that's
And
called
what's the
Infuro.
name? You changed your name though, too.
Yes. And yeah, the name of that is Infuro. So
Okay.
infuro.com. Yeah, that's the new name for the product for the company.
All right. So on to target though. What is your Postgres pet peeve?
Well, if I had to start from the top pet peeve is kind of meta, and I think it's actually its own success.
Okay.
So the fact that it runs in so many places and it has to be sort of a known entity and a known quantity to people, I think it precludes it from growth, not in terms of user base, like that's growing really well. But in terms of the software itself, the product itself, it's, to my opinion, is kind of stuck in the past. And the weight of the user base is kind of holding it there. And obviously not just the user base, but that's a big factor because it's harder to break things, harder to move forward.
I'm gonna agree and disagree. Okay, because and largely because I have been in the community for so long. Um, I agree with you. No, I agree with you on the Postgres is stuck in the past. It absolutely is. And it in a lot of ways, the community, and when I say the community, I'm talking about the hackers. I'm not talking about the users. Are more concerned with the reputation of Postgres than with building a superior product. Now, there's a good that comes from that, and the good is that Postgres is relatively predictable, right?
Yes.
And let's be honest, most people don't run Postgres. They run some variant that people have modified. RDS, Aurora, DSQL, Citus, well, Citus is an extension, but the whole bit, right? Neon.
Right.
They're modified versions of Postgres that allow a truer performant production situation. AlloyDB is another good example. I don't think it's the user base that causes that, right? The user base clearly demands more, which is why all of those forks are so successful.
Hmm.
I
That's
think
fine.
it's largely the community having a very narrow mindset of what Postgres should be. And again, there is a plus. The plus or the pro on that is that it's reliable. If I were to read Practical PostgreSQL, which came out 24 years ago, and I launched Postgres 18 today, it's largely still relevant, right?
Hmm.
I mean, we still have shared buffers, we still have workmen, we still have vacuum. Things have changed, like vacuum's much more efficient and those types of things, but it's something that's still it hasn't gone through a massive exponential shift in identity, right?
Yeah. Pros and cons. You put it very
Exactly.
spot on.
So if it now that's like you said, that's kind of meta. So what on a technical,
On a
what's the
technical
grumpy
side, yeah.
Yuri say?
Right. Well, the grumpy Yuri has a lot to say. Uh, I think actually a lot of this is still very much downstream from that meta. I mean, it kind of starts from the head,
Sure.
but it's basically the kind of the inability to move forward with some of the technical decisions that were made in the past. Obviously, there's some work being done in some of those. So let's touch on some, like for example, the storage.
Mhm.
And the
That's been a
fact that
common
it's
complaint.
still very baked in. Like I remember 2 years ago, I tried to implement my own storage. I wanted an in-memory storage, just to give an example. And when you started, it seems to be like, okay, we have an API for that. You know, let's just plug it in and everything will work. Except that you realize that it's actually different subsystems sort of overlapping there, like the transaction subsystem and the storage subsystem. There, there's not a clean way to actually add just the storage layer. You have to
Mhm.
really understand it. Whereas I've talked to people who build their storage engines. There's a few interesting projects going on right now, like brand new, relatively speaking, projects, and their integration with MySQL was like a couple of days.
Right.
Just go in and do it, right? And that actually really uh, hinders Postgres' ability uh, to basically reverse or improve on decisions made decades ago. Because
Yeah,
we're
and
we're no longer running the same hardware, same capabilities. It's
well,
totally different story
we
now.
have virtual machines that are far beyond the hardware they could even imagine decades ago.
Right.
Storage is a common pet peeve that we've talked about in the past. In fact, up on LinkedIn, I just had a conversation with Hanu about this. And I think it's important to recognize that, the way the storage engine is designed in Postgres is it's designed to work great for 90% of installs or 99% of average installs. And that is true, it does. The problem is that if you are hacking, developing, engineering for success on the average, you are hacking, developing, engineering for failure. And I think that is where a lot of people get frustrated is that eventually you, me, a lot of other people in the community, we move beyond the average. And we want to love our database, Postgres, beyond the average, right?
Yeah.
And now let's be clear, there's a pro to the average. Command prompt exists. My company exists because people can't deal with the average. They move beyond it. So they employ us to say, how do we work past the average? And we know all the tips and tricks. And we also have the engineering prowess to work around versus through,
Right.
right? But you're right. I mean, it's when you reach beyond that average, when you're reaching for, the stars with Postgres, you will run into limitations very quickly that you need to work around, and it is 100% centered around the storage.
Yeah. Storage and it leaks further. That's kind of the interesting part. The way we think about storage in Postgres, the way we think about tuples, everything. For example, we can't really go into any sort of reasonable OLAP. That is, we don't have columnar. I mean, there's obviously projects that are trying to do that now,
Sure.
but
C store, yeah.
yeah, yeah, etc. But there's super base funded efforts on that end as well. But basically, the problem is that even our query planner is row oriented,
Mhm.
right? It's like not the planner, the execution of the
Yes.
of the plan,
It's
but
cost
still,
based
it's
against each,
both
yeah.
planner and executor are essentially hard coded to that. So it's also kind of maybe side stream, not downstream from the storage, but they're all kind of intertwined, and we can't really change anything about that. And as you said, it is correct that for a lot of cases, this is just fine because most of Postgres deployments are actually pretty small. Like
Mhm.
we run a couple for our like control plane. There's nothing interesting about it, really, right? It's just control plane, like user accounts, stuff like that. There's
Right.
just nothing we expect that is sort of above and beyond at this scale. But it also means that our baseline is really low, like in Postgres, right? We know that, for example, if you work with your storage hardware in a different way, you recognize that, well, SSD is the primary way. For example, we store data. We can do completely different picture. Like we can move that baseline way higher, and that means that people will consider Postgres where they don't consider it today
Right.
because they're like, well, it's just too dated, right? So I think fortunately or unfortunately, we have this working and reliable system, but we don't have a good way to experiment. It's not only about like, hey, I've got a greater thing here. It's also about just being able to experiment cheaply. As you can see with the whole AI story, people are experimenting a lot because the
Yeah.
cost of experimentation has gone down, right? Whereas in Postgres, the cost of experimentation, especially on those particular areas, has not gone down, even with AI, because it's just so tightly sort of interwoven. That is a big problem, right? People can't just drop in and try something, an idea, not a final
So,
product, an idea.
it, an MVP prototype, whatever, right?
Yeah,
And you're right. It's very difficult to do so if you don't have an engineering team and a lot of capital behind you. And as evidenced by the fact that, the people that are doing the really interesting stuff are heavily funded. Supabase, Planet Scale, Google,
right.
Amazon, Microsoft. That being said, one of the things that I keep telling people, and most people don't disagree. I mean, I would, if you were to go to someone who was an old school hacker of Postgres, and the response was, all your, arguments may be technically valid, but the reality is we won. Okay. And my response to that always is, no, you didn't. All you did was make a standardized dialect and protocol, because if you had won, all those firms I just mentioned wouldn't have to deploy their own version that you don't have access to. Right? All
Yeah.
right, folks, that's been another T3D Sessions. Yurii, thanks so much for joining us. And again, come join us at Postgres Conference, April 21st, 22nd, and 23rd for Postgres Extensions Day in San Jose.